importance gives us the features that affect the predictions. The partial dependence plots, on the other hand, they tell us how a feature affects the predictions. So feature importance gives us the features that affect the predictions. It just tells you like age affects the prediction, this affects the prediction. But partial dependence plots, they show you how that age has affected the prediction. You get it? It doesn't show you, it tells you how the age has affected the prediction, how what has affected the prediction. So partial dependence plots were introduced in the context of gradient boosting machines. You can read more about the same in that greedy function approximation paper I've attached. And then partial dependence plot is calculated after a model has been fitted. And when we are talking in the morning, we have post hoc and intrinsic, right? Model. So we're looking at before, after the model has been trained, is when now we come back and say, okay, let me try and explain. I've already built this model, this is the prediction I'm getting. How did we get here? You get it? So don't worry. Those that were then, my first question will explain to you what post hoc is, what intrinsic is, global is, and everything. And then we also make sure that the model has a good predictive performance, or in other words, you have trained a good model before inspecting importance of its features. There is no point to. So throughout this notebook, I'm still waiting for Sabrina to tell me what time I have left. I don't know where Sabrina is. We are going to be working around partial dependence plots on the preprocessed version of adult income dataset using scikit-learn. So we talked about this example in the morning where he said, but now we're going to look at, we don't have data on Uganda, but we have data on the US. So we'll be using that data to see if we can actually explain what our model is doing. So the first thing is we'll import and process our data set. Then we'll compute and plot 1 and 2-dimensional PDPs. PDP is partial dependence plots. And then we'll explain the results. So these are the steps. You know what you are doing, eh? Sharp, sharp. So this is our case study. I already introduced this case study strategically because that's what we are going to talk about. So this version, and these are the features we are working on. We have the age, the working class, the marital status, the occupation, race, sex, hours per week, and then the income that a person's earn. So that can be either lower than 50K or above 50K. So yeah. So just a thing to note is that the attributes might be different based on the source of the data set and the version you're using, because this, from the time I created this code lab, a lot might have changed on Kaggle. So when you go and pick it, some things might be different, but you can pre-process it to what you are seeing here. So what we start with is we start by importing the necessary libraries. So you've already been shown how to build models, right? From previous speakers. We had a PyData talk yesterday. So I wouldn't want to focus on showing you how we build a machine learning model. I want to focus on showing you how we explain a machine learning model. Are we together up to that point? Because I'm assuming if you've not built models before, probably during PyData mini conference yesterday, you at least got to build some models and also to save time. Because I'm also still waiting for Sabrina to tell me how many minutes I have so I can rush. Where is Sabrina? You're not tired of me mentioning your name like this? Or anyone that's from the technical organizing team can help me. Yes, I'm seeing Sumaya is here. So Sumaya can look for Sabrina and help me know how many minutes I have left. Thank you. Let's continue. So we import the libraries. This is just normal. Import NumPy, NP, Pandas, Matplotlib, Seaborn, blah, 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 blah. All of them. And then np-random.seed, import warnings. So this is just the things we always do. And then we set up styling for plots in our plot. And then we are now reading the data set. So this is what, Sabrina is here. This is what our data set has. So you have the age, the working class, the education, marital status, occupation, race, gender, hours per week. And the income is in zeros and ones. So if it's 0, it means they don't make above 50K. If it's 1, they make above 50K. Makes sense, eh? Yeah, nice. So we just do the data.info. You just get information about your data set. And then you are looking for missing values, none. So now we train our data set. 10 minutes. Okay. Yeah, I'm loved. So you relax. It's not up yet now. So yeah. So we train our data set, we encode the categorical values. Let me now explain this part, maybe some others are a little bit beginner. So we encode categorical values because, computers don't understand words. They only understand numbers. So if something is in words, it's hard for us now, our computers, to understand X, Y, Z. That's why we encode it first before now passing it on to what we are doing. Are we together up to that point? We are together? Okay. And now we train our classifier. So remember, this is a classification model. We are trying to classify if someone earns above or below. So we only have an output of only two things. Either you are rich or you are poor, right? There is nothing like in the center or medium, no simanya what. You either you are rich or poor, 50K and above or nothing, right? Let's continue. So that's what we are trying to do. And then now from there, we now have a model and our prediction. So now let's start. Well. So let's now explore the different ways which we can understand the model and its predictions. So here is a step-by-step of how we calculate partial dependence plots in our model. So the first thing is we've trained a model, we've done that. Then we set all the values of the features of interest to a particular value without touching any other values. So the ones that were in my first session. So here now, the feature of interest, during the first session we said that we'll only look at the age, right? So now here the feature of interest will be the age. So we're looking at if we vary the age and leave everything constant, how has it affected our predictions? You understand, You are getting the gist. This is the good thing of following me in my sessions, if I'm doing them, so that you are sharp. And then, now from there now, we make predictions on the modified data set using a previously trained model. So we keep on changing, making predictions, getting the average. Changing, making predictions, and then we average all our predictions. So this can be challenging for those that are not in the first session. Now they don't understand, I'm just speaking gibberish to them. But that's why we have someone next to you that was in the first. You are there now. You can explain to them. Sharp. I have 10 minutes too. So I have to be sharp and explain. But I will still revisit it. I'll start a YouTube channel. So you can come and learn more. You will subscribe if I start. Will you subscribe? Okay. So yeah, that's how we work around that. So this is how we do it. So the first thing is we import partial dependence. So you see here, sklearn.inspection module provides a convenient function which is called plot_partial dependence. So we're now going to use that function to achieve what we want to achieve. So to do that, well, let's plot one-dimension plots first before we proceed. So we'll import the partial dependence display, and then we look at the sample, grid solution, and random state, and then now look at the features of interest. So we have age, hours per week, working class, and education. So those are our features of interest. Those are some of the features that will be varying around to see what we are getting. And then now from there, we look at the categorical features. Remember when we were encoding them. So we look at them, and then I'm still waiting for the 5 minutes card to be raised. So it hasn't been raised yet. You wait. I have to explain to them what they are seeing like this. Then I'm done now. So yeah. So we are now looking at partial dependence. I think this is where now I can explain better. So you're seeing now we are having age down here, and then we're having partial dependence up there. So how dependent is this? How dependent is this age on the prediction that I'm getting? So when you look at people above, just past, when you look past the 38 or 35, 38, close to 40, you are starting to see like it's starting to be flat on the first graph, like this first graph. You're seeing it's starting to be flat. This means that probably people above that age are slowly starting to get out of the workforce. So it's not really like, they don't work hard like us young people. Up and down here, we hawk in the evening. During the night, I'm a watchman somewhere, guiding someone's home. During the day, I'm here delivering content, doing the Lord's work. I preach to you guys. You see, that's young people like us. But for old people, they are already tired. We give them money, which we do it from the bottom of our hearts, right? They are our parents. Now we have to take care of them. So yeah, that is how you get to understand how that specific feature is having a high dependence or a low dependence on your model. So we have ICE plots, but I didn't get to this in the first session, so I don't want to confuse you guys. I'm still having like 2 workshops to go tomorrow. I'm seeing one of my co-speakers already here. So the partial dependence plot shows the average effect of the features of interest, while individual conditional expectation plot visualize the dependence of the prediction on a feature for each sample separately. This is technical, right? Sorry, I want to speak Swahili. I have confused you guys a little bit, right? Now, let's be honest, right? Now, for me, I'm honest when I know my audience is out of range. Are you in range? Are you in range? No, you are not in range. I also know you are not in range. But Sabrina hasn't raised the red thing yet, so I can try to cover it up a little bit. So, what I'll do to help you folks better, you see, I have attached references, and this is you can follow along what I've shown you, right? It's something you can go along. But during my workshop tomorrow, I'll try and now come back and explain the coding bit to you slowly by slowly, just like I did to help you understand the other theoretical concepts of explainability. It's very important for us, people in the ML field, to start looking at responsible AI in terms of 4 aspects. So a quick explanation of what PDPs are. Who can tell me what partial dependence plots are? Like, I know I've rushed, but who? Before Sabrina chases me. Who can tell me what partial dependence plots are? You mean even from the... You come and tell me. You also have to be heard. They have to see you online now. You come. Hey, they have to know who you are. You come here so that this microphone also gets you. They also, see how sharp you are. You're a sharp boy. You don't worry. You get it right. You're a sharp boy. So, yeah.
So partial dependence plots are just a plot to show one variable that has been changed while keeping others constant. Say you're trying to observe how changing the ages of people will affect the salary they earn, but given you keep all the factors constant, education level, their experience and all that, yeah. That's what I think it is.
Okay. Clap for him now. You stay. I'll give you something. They didn't want to come. So, yeah. Has he gotten it right? No, before I give him the gift, has he gotten it right? The one that I in my first station. He has gotten it right. You agree? So if I give him the gift, he has earned it. Yeah. So let me give you the gift. The others that did come, I don't know. So everyone wants this one, but you have it. You see how sharp you are? Everyone wanted this one, but now he has it. So will you have it too? Will you have it too? It's here, but you don't have it. It's here. Don't worry. Come and take your gift. Photographer is here. We must be. You want this? You want? You can get it. They didn't work hard, so you can. Yeah.
Here is your red card.
Yeah. Take a good photo. Anyway, let's try. You know what? You don't have it. Okay. Okay. You enjoy. How do you feel? You yeah. So if you come, I have really rushed, but at least people have learned something small, eh? Yeah, so now next time, more gifts, more gifts. All those will be gone by the time you are leaving the conference. Will you be the one getting them? Thank you so much. You can follow me on GitHub at Mwanyumba7. That's where you will get to know more about me. Okay, bye. See you.